Chapter 1, Lesson 1.3, First Electronic Computers, Turing, ENIAC, and Von Neumann. World War II changed computing forever. 3 urgent demands made it happen, breaking enemy codes, calculating artillery firing tables, and coordinating global military logistics. Human calculators were simply too slow. The pressure of war forced the invention of the first electronic computers, and the theoretical framework that still powers every device today. Before any computer existed, a 24-year-old named Alan Turing published a paper in 1936 that defined what computation actually means. His imaginary device, the Turing machine, could simulate any algorithm by reading and writing symbols on an infinite tape. He also proved something profound. Some problems are mathematically impossible for any computer to ever solve. That is the halting problem. Every concept of algorithm and computability traces back to this single paper. Turing is rightly called the father of computer science itself. In 1943, Turing led the team at Bletchley Park that cracked the Nazi Enigma cipher using Colossus, the world's first programmable electronic digital computer. Processing 5,000 characters per second, Colossus decoded encrypted messages that changed the course of the war. The project was so sensitive it remained classified for 30 years. Turing's contribution is estimated to have shortened World War II by 2 to 4 years and saved millions of lives. In 1945, the ENIAC arrived, the electronic numerical integrator and computer, the first general-purpose electronic computer. It weighed 30 tons, filled a 10-meter room, contained 18,000 vacuum tubes, and consumed 150 kilowatts of power. It could perform 5,000 additions per second, 1,000 times faster than any previous machine. But to change what it calculated, engineers had to physically rewire the entire machine. No stored programs, no software. Also in 1945, mathematician John von Neumann published the blueprint that changed everything. His architecture stored both programs and data in the same memory. This single idea meant you could load different software without touching the hardware at all. Input goes in. Memory holds both programs and data. The CPU executes. Output comes out. Every laptop, smartphone, server, and microcontroller ever built uses the Von Neumann architecture. It is widely considered the most consequential engineering blueprint in the entire history of computing. But this architecture has a fundamental flaw. The CPU is often much faster than it can fetch data from memory, so it sits idle, waiting. This is the Von Neumann bottleneck. Modern processors tackle this with layered cache memory. L1 cache is closest and fastest. L2 is a little slower. L3 is shared across cores, and main RAM is the slowest of all. Keeping frequently used data close to the CPU is the key to modern performance. Quiz. For this lesson, now test yourself. What makes the Von Neumann architecture the foundation of modern computing? Read each option carefully. The right answer is the one that defines the stored program concept. A. It used vacuum tubes for the first time. B. Programs and data are stored in the same memory, enabling software to change without hardware rewiring. C. It invented binary number systems. D. It was the first computer to use transistors.